Hi, I'm DJ Spiess. The speed at which we deploy our microservices is critical for creating a functioning system. If we can't deploy fast, we can't scale. In this video, we're going to look at a few scaling issues we must address when deploying our microservices. When you think of a microservice, think of a cat. A little effort, and you could probably get it to do what you want. Now, imagine adding another cat. It takes a bit more effort, but you could probably manage them. Now think of adding hundreds of cats, maybe even thousands. That's the challenge we face with large microservice systems. Lots of little slinkies with fur, and without a plan to manage them, it's chaos. There's many areas to discuss when scaling your microservices, and we'll eventually get to all the ones I know about. But for now, we're going to focus on one pain point at a time. In this lesson, we're going to address scaling issues when deploying microservices. So to succeed at microservice architecting, we need a controlled way to introduce new microservices into our system.
Here's the first area we need to focus: continuous integration. The way this works is our developer issues a pull request for a Git repository. To keep the workflow simple, we'll assume this work was for an approved feature or bug fix. The pull request triggers a workflow, usually executed by something like Jenkins, but we can insert our favorite scheduler here. The pull request then goes to a peer review. That's why I'd use a pull request instead of pushing code. Pull requests make the peer review simple. On approval, the code gets built, packaged into a Docker container. It's tested, stored into an artifact repository, and then it gets deployed. Every step in the process we make automatic is going to make our lives much better. Once the code is accepted, it should be automatic all the way to production.
So what does this buy us? Well, with automatic workflow, we can shepherd new code into a system very quickly. This is true for any system, not just microservice architectures. Here's why it's critical for deploying microservices.
Continuous integration allows us to deploy to production hundreds of times a day. The more automatic we make deploying to production, the less it's a pain point for us. That's important because we're trying to deploy hundreds of microservices. Our process should not take days, weeks, or heaven forbid, months to deploy a release. If it takes longer than the time it takes to push a button, our deployment process is too long and it will kill us. Push button deployments will also make it easy for us to roll back if we need to. Just push the button to deploy the previous version. Kill the new version instance and we're done.
This also allows us to forget about instances that are going sideways. If the container has a glitch or the machine the service is running on is failing, kill it. Start a new instance on another machine. Done.
Putting our code into Docker containers makes the act of deployment the same for every microservice every time. The action is run this container. We can specify the compute requirements, but at the end of the day, we don't care where it's run. So at some point in our system's life, our system administrator is going to come to us and say, hey, we don't have any more room for compute. We can't scale until we get more hardware, and that process will take weeks. Well, if we don't care where our microservice is run, we can deploy anywhere. Running in containers allows us to do something called cloud bursting. That means when we run out of compute on our data center, we can scale up on cloud services like Amazon or Google. We'll use something like Kubernetes to orchestrate scaling up, scaling down, and cloud bursting.
Another thing we'll need to do to keep deployments easy is more of an architectural issue to address. When we design our microservices, they need to be stateless with zero dependencies. Now, I don't mean the microservice processes can't be in a state. Stateless means that any microservice instance can handle any request at any time.
It doesn't need to be a particular instance. If our sales microservice needs to talk to a particular order microservice, and only that microservice, we have to replace both just to replace one. That makes the two microservices pretty much one microservice. Keep doing that for all of your microservices, and suddenly you're replacing the whole system every time. That's no good because it forces us to deploy far more than we need to. We do not want deep dependencies between microservices either, for almost the same reason. The more coupled our microservices are, the harder it is to deploy one without the coordination of another. The more this happens in our system, the more our service looks less like microservices and looks a lot more like the monolith system we're trying to escape. This means we need to design our microservices to fail gracefully and function when other microservices fail. To make deployments truly independent, every microservice must be able to function in a vacuum. and wait till other needed services are available.
So that's a few things we need to be able to scale easily. I'm sure I've missed a few things, so let me know what I've missed in the comments below. If you like this video, make sure you like and share. This helps get the video in front of other viewers. New videos come out each week, so make sure you subscribe. You don't want to miss a video. Thanks for watching, and I'll see you in the next video.